Hey, Layla, Mr. Chappie here. I was looking over your work for this last question, and I finally figured out what went astray. Like the previous one we talked about, your work is good. Your work is pretty impeccable. Your setups are pretty good, but it seems like you encountered a situation that I think I discussed in one of the videos, but it might have been for a different class. But regardless, let me show you where that situation is. You had decided to multiply everything by that right there, which isn't necessarily a bad thing, but you're using too many h minus threes. Like when you did it here on the first fraction, I will learn to use this tool one of these days. When you did it here on this first fraction, you did it correctly because you're left with a 15 there and the h minus 3, which you distributed to get this. So that part was good. And but when you did it on the second one, right here, we'll put that in red. There we go. When you set up the second one and got this is where things went a little bit off. I'm trying to get this to cooperate. There we go, right there. All right, so when you did this part right here, that's where things went a little bit off, because what you did was you distributed. Let's see if I can get this to, let me turn my picture off. It's blocking some of the things that I'm trying to look at. When you did, what it looks like you did was you distributed the 5. You distributed the 5 across here. No, wait a second. What did you do? It's going to say you distributed the 5 across there and also across here. Or is it the negative 5 that you distributed? Okay. So the problem came in that you're using too much when you multiply. So let me go to the whiteboard and show you how to play it out. Pause this for a second. All right, I've got the equation up here and the factored version of the denominators. You did that well. However, when you multiplied to cancel all your fractions, you gathered a 5, you gathered an h minus 3 and an h minus 7, and then you gathered another h minus 3. Now, I'm not sure if you used 2 h minus 3s because you saw 2 of them down here, but if that was the case, why did you only use 1 h minus 7? Because there's also 2 of them down there. The problem with using the h, well, first off, you don't need to use the h minus 3 twice. Let me bring my picture back in here. You don't need to use the h minus 3 twice. And the reason is, within any single fraction, you only have one h minus 3 to get rid of. In the first fraction, that's the only h minus 3, just a single one of them. And over here, that's an h minus 3, but just a single one of them. So really, I only need this first part in order to successfully knock out all 3 fractions. So we're going to multiply everything by that. All right, if we multiply all 3 fractions by 5 h minus 3 and h minus 7, then there will be plenty of ammunition to cancel all the fractions. The h minus 3's cancel here, as do the h minus 7. That leaves 3 times 5, which is 15. In the second fraction, only the h minus 7's cancel, leaving a minus. 5 times 5 is 25. And we still have this h minus 3 in parentheses. We'll distribute in a moment. And on the last fraction, the 5's cancel, and the h minus 3's cancel, leaving just the 1 times h minus 7. The 1 times anything is itself. Now, I'm going to assume that you can finish solving it from this point forward. But this is what the equation should have looked like had you multiplied everything by the smallest, the least common denominator of 5, h minus 3, and h minus 7. So what happens if you use extra stuff? I'll show you what happens when you use extra stuff, and I'm not going to do the entire problem, but I'm just going to show you what would happen on that middle fraction, the one that had minus 5 over, what was it, h minus 7. And then you multiplied what you had done was multiplied by 5, h minus 3, h minus 7, and another h minus 3. Now, had this happened, and there are scenarios where this would be the correct setup, if in a single fraction you had a pair of h minus 3s that you had to cancel at the same time. But if you use more than necessary, here's what happens. You still have the canceling, but then you got a lot more stuff left over. You've got the negative 5 times 5, which is negative 25, and the h minus 3, and the h minus 3. And the question is, what do you do with this? Is it a distributive property? If it is, do you distribute on the front, on the back, or on both? Is it a FOIL problem? And if it is, what do we do with the negative 25? But I'm pretty confident that I mentioned this in a previous video. When you're multiplying and you have the distributive property and FOIL first. If you distribute, that's fine, but you only get to distribute across one parentheses. However, it might be more beneficial to FOIL this out. And you would get eventually h squared minus 6h plus 9. Then you could distribute and get negative 25h squared plus 150h minus 225. Oh, so sorry. But I would not recommend this course of action, because by bringing in that extra factor, by bringing in the extra h minus 3 right here, which wasn't necessary to get the job done over here, but by bringing it in, it creates an h squared. In other words, it creates a quadratic equation when there was not one. So could you solve it? Yes. Would you get an extraneous solution? Actually, you would. Would I recommend multiplying by more than is necessary? I would absolutely not. You want to keep the stuff that you multiply by at a minimum, because that way what's left over is as small as possible. This equation down here is linear. Pretty easy to solve. I'm so sorry, Layla. I am so sorry. This equation is quadratic. And although we can solve it, I would rather solve a linear. So the best advice I can give you when you're setting up a problem like this, and I'm going to undo a lot of this just so we can get back to the problem before I attacked it. When you get a factored version like this, where the denominators are factored, and you start building your least common denominator, it doesn't have to be the least, but it will leave the problem in a better place if you use the least. All you have to do is grab each factor, the most number of times it ever shows up in a single fraction. The h minus 3 only shows up once in any given fraction, so I only need one of them. Then grab your next factor. And again, I only need it as many times as it shows up in one fraction. The h minus 7 only shows up once in each fraction. And then the only piece not accounted for is the 5. Now, I'm going to put this back the way I found it just a second ago, in case you didn't write down that equation. But then again, it's a video. You can go back and watch it again. So go see what was left over after I multiply by the least common denominator, solve that, and you should be good.